This is video 10 untitled case study. Along this video, we consider a deterministic tile assembly system T and a path assembly P which satisfies macroscopic conditions in the shift constraints for index S according to vector V. The assembly alpha is the unique terminal assembly of the tile assembly system T. We present here the study of three cases. We show that the path assembly P is pumpable for each of this case. In the next video, we will put all the pieces together to prove the main result. The first final case is called jail. Consider the example of the right side. This path assembly has to satisfy two conditions to match the jail final case. First, consider the square of width b5 plus 1. Note that the value of this bound can be found in the appendix of the article available online. Now we consider an index I1 and we suppose that the segment of P from its first tile to I1 belongs to the square of width b5 plus 1. Now consider the segment of P from I1 to the last tile of P. Suppose that the segment does not intersect with its translation by minus V. If these two conditions are satisfied, then the path assembly P matches the jail final case. Now, we show that if P matches the jail final case, then P is pumpable. Consider now the square of width delta of b5 plus 1. Remark that the last tile of P is not inside this square. This is due to the fact that the bound b6 is equal to the width of this square plus 1. Then the jail lemma can be applied and the path assembly P is pumpable. The second final case is called avoids the shift zone. In this case, we do not draw the seed and the path assembly. Instead, consider the shift zone, that is to say the square of width b4. Now we suppose that there exists a good segment of P of direction V or minus V. This segment starts in I2 and ends in I3. We represent here the case where this segment is of direction minus V. Now we want to extend this segment in direction V. Thus we start by switching the direction of P and we obtain a path assembly Q of direction V. Now we extend Q in the direction V. Since by hypothesis, this segment is good, then we obtain an infinite path assembly R. The index J1 is chosen such that the segment of R from 0 to J1 is the path assembly Q. Now we suppose that this infinite path assembly does not intersect with the shift zone. If these conditions are met, then we say that the path assembly P matches the avoids the shift zone final case. Now, we prove that if a path assembly matches this final case, then it is pumpable. Since P is producible, then the assembly induced by the segment of R from 0 to J1 is a subassembly of the unique terminal assembly alpha. We represent these tiles in gray. They belong to alpha. Now suppose that the assembly induced by the path assembly R is a subassembly of alpha, then by definition the segment of P from I2 to I3 is pumpable. For the sake of contradiction, suppose that the segment is not pumpable. Consider the index J2, which is the first inconsistency of R, then the subassembly induced by the segment of R from 0 to J2 is a subassembly of alpha. The tiles of this segment are in gray. Also, the growth of this assembly is blocked by an obstacle. This obstacle is in fact a tile of P of index I4 with I4 greater than S. Indeed, the seed and the segment of P from its first tile to S belong to the shift zone, and by hypothesis the path assembly R does not enter in this zone. Now consider the translation of Pi4 by minus V. Since the path assembly R is periodic, then the tile RJ2 translated by minus V is the tile of R of index J2 minus J1. Then this tile is inconsistent with the tile Pi4 translated by minus V. Then the tile Pi4 translated by minus V is inconsistent with alpha. This is a contradiction of the shift constraints. The third final case is called enter the shift zone. Consider the shift zone, that is to say the square of width b4. Now we suppose that there exists a good segment of P of direction V or minus V. This segment starts in I2 and ends in I3. We represent here the case where this segment is of direction minus v. Now we want to extend this segment in direction v. We suppose that this extension intersects with the shift zone. Also there should exist an index I1 such that I1 is less than I2 and the position occupied by the tile Pi1 is not in the square of width B5. If all these conditions are met, then we say that the path assembly P matches the enter the shift zone final case. Now, we prove that if a path assembly matches this final case, then it is pumpable. Since the extension of the good segment intersects with the shift zone, then there exists an integer k and an index I4 such that the position of the tile Pi4 translated by kv is in the shift zone. Moreover, I4 is between I2 and I3. By the shift constraints, the ordinate of v is strictly positive and k is bounded by b4. Otherwise, the translation of Pi4 by kv would be too high to be in the shift zone. This also means that the ordinate of Pi4 is less than b4. By the shift constraints, the norm of v is bounded by b2, and since k is bounded by b4, then the abscissa of Pi4 is less than b4 times b2 plus 1. Then the tile Pi4 is inside this square. Now we do not need to consider the shift zone anymore. Consider the square of width b5. We conclude by using the second hypothesis of the enter is the shift zone final case. There exists an index I1 which is lower than I2 and such that the position of Pi1 is not in the square of width b5, then it is possible to use the reset lemma to show that P is pumpable.